So we're starting now. So good afternoon. My name is Marvin Manalastas, and this afternoon I will be presenting high-level details or information about Keras. So with me here is Usama. He will also be presenting Keras. So we have decided to split the topic. So I will be presenting the high-level ones, while the sample and application of Keras will be presented after this. So let's begin. So the contents of my presentations will be, first, what is Keras? So secondly, we will be discussing what are the key features of Keras. And thirdly, we will be tackling why we should use Keras, what are its advantages. Fourth, we will introduce, this is just a very brief introduction on how to implement Keras on a neural network. So firstly, what is Keras? So firstly, Keras means horn in Greek. So I just found it interesting because I don't know what Keras means. So Keras is a Greek word which means horn. So Keras is an open source neural network library written in Python, and it is an API for specifying and training differentiable programs. So as I've said, Keras is a front-end layer written in Python that runs on top of other popular deep learning toolkits like TensorFlow, Theano, Microsoft Cognitive Toolkit, and Plate ML. So any piece of code you write with Keras will run on these backends without having to change any of the code. So via TensorFlow, Theano, and CNTK, Keras will run seamlessly on all of these GPU, CPU, and TPU. So Keras is the official high-level API of TensorFlow. So as we can see here, this is the hierarchy. So it is the official high-level API of TensorFlow via the TensorFlow.keras, tf.keras module. So Keras has been part of the core TensorFlow since version 1.4. So it is better optimized for TensorFlow and better integration with TensorFlow specific features. So by establishing the Keras as the high-level API for TensorFlow, we are making it easier for the developers and new machine learning to get started with TensorFlow. So a single high-level API reduces confusions and enables us to focus on providing advanced capabilities for the researchers. So next is, let's discuss the key features of Keras. So Keras is used for fast prototyping, state-of-the-art research, and production. So first key feature of Keras is that it is user-friendly API. So Keras has simple, consistent interface optimized for common use cases. It provides clear and actionable feedback for user errors and easy to understand error messages, often with helpful advice. So next feature of Keras, it's modular and composable quality. Keras models are made by connecting configurable building blocks together with few restrictions. The third key feature of Keras, it is easy to be extended. We can write custom building blocks to express new ideas for research, including new layers, loss function, and to develop state-of-the-art ideas. So Keras is easy to be extended. And lastly, Keras is developed for both beginners and for experts. Deep learning developers comes from many background and experiences levels, and Keras provides helpful API whether you are an experienced or beginning in this field. So next slide will be the who makes Keras and the contributors and backers of Keras. So this guy is the primary author and maintainer of Keras. His name is, I don't know how to pronounce it. He's a French, I think. So he's now in Google. He's a Google engineer now. So Keras development is backed by key companies in deep learning ecosystems. So there are total currently, or I think this is back in 2008, there are 633 contributors, and it is backed primarily by Google. So additionally, Microsoft maintains the CNTK Keras backend, and also Amazon's AWS is maintaining the Keras fork with MXNet support. So other contributing companies include NVIDIA, Apple, Uber, and Uber. So next slide will be on why we should use Keras. So Keras prioritizes developer experience. So firstly, Keras is an API made or designed for human beings and not for machine. And therefore, this makes Keras easy to learn and easy to use. However, even if it's easy to learn and easy to use, Keras, this is of use that does not come at the cost of reduced flexibility. So because Keras integrates with low-level deep learning languages, particularly TensorFlow, it enables you to implement anything you could have built in these languages. So in particular, as I have said, tf.keras, the Keras API integrates seamlessly with our TensorFlow workflows. Still on the why we use Keras slide is Keras has broad adaptation in the industry and research community. So currently, there are individual users of more than 250,000 users of Keras. So it comes close, or it comes second to TensorFlow. So also Keras has been second most favorite deep learning by the researchers. So in terms of mentions in scientific papers uploaded to the preprint server arxiv.org. So and lastly, Keras is also been adopted by researchers at large scientific organizations such as CERN and the NASA. So Keras also is especially popular among startups and that place deep learning at the core of their products. So we are not aware, but every day we are using or encountering some companies which uses Keras. So currently, there are around 3,623 companies which use Keras. So this, we can see that the growth is still trending upward. So we can expect more companies to adopt Keras. So these are the current companies which are using Keras. So Netflix, AT&T, and Huawei are the some of examples. Next is still why we use Keras. So Keras makes it easy to turn modules into products as model can be easily developed across a greater range of platforms than any other deep learning framework. So as we can see here, on iOS via Apple Core ML, so Keras support officially provided by Apple. So also on Android via the TensorFlow Android runtime. So in the browsers via the GPU accelerated JavaScript runtime such as Keras.js and WebDNN. On Google Cloud via TensorFlow serving, and on Java via this module by SkyMind, and also on Raspberry Pi. So lastly, for the why we use Keras, is Keras supports multiple backend engines and does not lock you into one ecosystem. So available backends includes, as I have mentioned earlier, TensorFlow backend from Google, CNTK from Microsoft, Theano backend, and MXNet as backend from Amazon. So as such, our Keras model can be trained on a number of different hardware platforms beyond CPUs. So this beyond CPUs including GPUs and TPUs. And also Keras has strong multi-GPU support and distributed training support. So in terms of job opportunities, knowledge in Keras is also one of the leading in-demand skills. So as we can see here again, it is second to TensorFlow in terms of job mentions in this particular site, Hackers News job board. So given that Keras is only it is made back just in 2015, so just 4 years ago, its growth is really outstanding. So this will be the last part of this presentation, just the basic implementation of Keras in a neural network. So basically there are 5 major steps in doing this. So firstly is preparing the input and specify the input dimension. Next is we define the model architecture. Next is we choose the optimizer, either SGD, RMS Prop, or Adam. Next is the loss function, either MSE, cross entropy, hinge, or other loss function. And then we will train and evaluate our model. So these are the sources in creating this presentation, and thank you.
So any guys have any questions? it's a little bit short presentation, I guess. So, I just have a question. Like, why we should even bother with like TensorFlow then?
Sorry?
Why should we still use TensorFlow then? Like, it seems like Keras covers everything.
Did you get it? So why do we have to use TensorFlow if Keras does everything?
Ah, okay, so based from, no.
It's over there.
So based from what I read, so Keras is wait. Okay.
Can you listen to us?
Sorry.
Can you listen to us?
Yeah, I think so.
Let me put it another way. I'm quite curious because you have like still TensorFlow is most popular, right? Or in the sense like, for example, you show the job hacker or whatever that website, or hacker.job or whatever, like it's still like TensorFlow is most still like it's everywhere. So, but you also mentioned most of the companies like just go ahead and use Keras. So why should we bother with like TensorFlow exactly?
Because I think the interface or Keras is easier to use than TensorFlow.
Any limitation on the part of Keras, like anything you mentioned, like almost basically like everything that can be implemented like TensorFlow it can be implemented like using Keras as well. Is there anything that we must go back and like implement using TensorFlow?
So right now, sir, I'm not sure about why we cannot use Keras as just Keras itself, why it needs TensorFlow. So yeah, I think I need to dig in more on that.
Okay, I guess maybe the second speaker can answer that. After his talk, really, or like I don't know who is the first speaker for the Keras, maybe.
Me.
We can.
Yeah.
You're the first speaker, maybe.
So,
Okay. So
we divided the topics, so I will present the implementation or coding part of Keras now.
okay, yeah. So maybe you talk about what you have first, maybe
Yeah.
we can come back with more questions.
Okay.
Okay. Any others have other questions? Yeah, just.
It's my understanding that it seems that Keras is like maybe designed for people who are not familiar with programming syntax, and thus makes it more easier for them to perform their job functions. I heard that the primary author left and went to work for Google. What was the impact of that in regards to development and progress of Keras?
Closer, can you hear the question, like Marvin?
Yeah, I think the author is still maintaining he's still working and maintaining Keras.
Okay, so it must be something that he's doing on the side.
Yeah.
It's a passion project.
Yeah, so he's still the main maintainer, or he maintains the Keras still, the original author.
Or is he hired to just work on Keras like in Google, or like what do you know that was his exact kind of job title or well, I guess it's hard to think into that, but do it. Oh.
People say they die.
Yeah, but maybe Google just really put the best implementation for Keras for cancer for like better than maybe other backend or something like that.
Yes,
So you grab that guy then contribute on that.
Yeah.
So it's more compatible with TensorFlow other than maybe like
Yes.
and stuff like that. I don't know.
Machine learning and artificial intelligence department.
Why would Google hire a competitor like that?
Yeah, because just want to make him insider, right? One of them. So.
It's the code 50. What's the code? Stop. 507. 5700.
Hi, should I start my presentation now?
Yes.
Okay. So my name is Usama Masood. I am a PhD student here in Electrical and Computer Engineering department. And as Marvin already mentioned why Keras is mostly used, I will talk about the coding part of Keras a little bit. So yeah. So as already mentioned, so Keras is a top layer on top of the TensorFlow that makes it much easier to create neural networks. So it provides a higher level API for various machine learning methods. And I think the answer to your question is unless you are performing research into entirely new structures of deep neural networks, it is unlikely that you need to program TensorFlow. So right now we know that there are CNNs, RNNs, DNNs. So if somebody in a research community wants to create a new type of deep learning structures, then maybe he'll probably need to code on TensorFlow. Otherwise, as far as I know, he can work on Keras because it provides a much easier interface to work with on already created structures. So, and for installing Keras, you just need to on your Python terminal, you just need to write pip install Keras after installing TensorFlow, of course. So you will use Keras. So I'll talk about Keras coding now on top of TensorFlow. So backend is TensorFlow, and I'll talk about the Keras part. So let's take this example. So yeah. So for starting, after you have imported the Keras library, if you want to create a simple multi-layer perceptron or deep neural network, you have to write a sequential. Sequential is the model which is used to create feed-forward networks. So, and if you want to add some hidden layers into it, you just need to write model.add and then specify the layers properties, at how much neuron does it have, which activation function to use, what is the dimension of inputs. So on this current line, we can see that the input dimension is hundreds. That means there are 100 features in the input. So the first layer has 32 neurons. So it means that the 100 features are mapped to 32 neurons using an activation function called rel. And I will further explain each of these terminologies in the coming slide. This is just a brief, to know how does the code look like. And you then compile the model and then test it. I will go through each of these lines in the coming slides one by one. So for activation functions, which are applied on a per layer basis, these are the available options in Keras. So out of these options, softmax, ReLU, and tan hyperbolic are the mostly used activation functions. Other activations such as linear, sigmoid, hard sigmoid, soft plus, soft sine, elusive, these are all also available if somebody wants to use them. So these are the options available in Keras for activation functions. And these are the shapes of activation functions as Dr. Sam already mentioned in his lectures. Tan hyperbolic, sigmoid, soft plus, these are the shapes of different activation functions. And the next function in the hyperparameters of Keras is the loss function. So these are the available loss functions in Keras. Most of them for regression purposes we use mean squared error, and for classification purposes we use cross entropy functions. So, but these are also all the loss functions which are available in Keras. And if you want to specify which loss function you want to use, during compiling the model you just have to write loss equal to and then write the name of the loss function in quotes. That's it. You don't have to create anything extra. These are all available by default. So the next part is the optimizer part. So if you want to use optimizers, so Adam is the default optimizer as already mentioned. So it is much better than the traditional stochastic gradient descent, and that's why Adam is now the default optimizer in Keras. So if you even don't write anything, it will take Adam as the default optimizer. But if you want to specify, you just have to write, while compiling the model, optimizer equal to SGD for stochastic gradient descent or Adam for Adam's algorithm. So I don't need to explain what Adam is. It is already covered in the lecture, so I'll just stick to this. And for the regularizer part, so sorry. Our camera fell down. For there are three types of regularizers available in Keras. Number one is the kernel regularizer, which is applied to the kernel weights matrix. Second one is the bias regularizer, which is applied to the bias vector. And third one is the activity regularizer, which is applied to the output of the layer, which is its activation function. So these three types of regularizers are available in Keras, and you can use them on a per layer basis. And further, the available penalties or the available loss functions are L1 regularizers, L2 regularizers, or both. And you can even specify their values as well. So, yeah. And if you want to use them on any layer, so while you're adding a layer, you just have to write kernel regularizer if you want to use kernel, and then regularizer equal to regularizers, which is a library of Keras, dot L2, and in brackets you have to write their values. So in this layer we are using kernel regularizers with an L2 penalty and an activity regularizers with an L1 penalty. So both are applied on this layer in this example.
I don't quite understand this activity regularizer. The kernel and bias, I guess I can understand it because this is just a weight, right? And then in the sense, I either give it the L2 or L1 norm to add the additional cost, right? But what's that activity regularizer? So you said that it's applied to the output of the layer, so...
Yeah, so I think it... So the equation which is equal to Wx plus B. So the kernel is applied to the W vector matrix. The bias regularizer is applied to that B value B matrix, and the activities regularizer is applied to the whole Wx plus B. That's what I understand.
Okay. Okay. It looks a little bit weird to me though. I don't know.
I don't know much detail about it. Okay. And And the last hyperparameter, it's not hyperparameter, but you can use this, is early stopping. So if you run your deep neural network and specify the number of epochs to say 100 epochs, so if the algorithm sees that whatever the loss function, the mean square error, is not improving that much after some epochs, so it will stop the training process. So for using in early stopping, there are three parameters which need to be specified. Number one is the monitor, which value do we need to monitor? Do we need to monitor the validation loss or the actual model loss? And then minimum delta is the minimum change in the monitored quantity, say validation loss, to qualify as an improvement. So say after one layer, the mean square error of validation data is 4.5 and the minimum delta you have choose is 0.5. So if after another epoch, the mean square error only reduces from 4.5 to say 4.2. So the change in mean square error is 0.3, whereas the minimum threshold you defined is 0.5 to qualify for another epoch. So it will stop. That's the whole purpose of early stopping. And the third parameter is patience. So the patience is number of epochs with no improvement, after which training will be stopped. So by no improvement, it means improvement which is less than the minimum delta that we specified. So if I set patience is equal to 0, that means if after an epoch, the mean square error is reduced by 0.3, which is less than the 0.5 that we specified, so it will stop right away. And if I set the patience to 1, it will wait for another 1 epoch, and so on and so on. If I set the patience to 5, so it will wait for 5 epochs with no improvement or less improvement than the delta to stop the learning process. So this is actually very good parameter, because generally we see that the model loss is saturated after 10, 20, 30 epochs mostly. So it will stop the learning process to save the training time. And for using this, I don't know if you can see this line or not clearly. You just have to write monitor equal to early stopping, and the three parameters: monitor is equal to validation loss, minimum delta is equal to 0.001, patience equal to 5, and then I haven't explained verbose and mode actually, and then use this monitor in the callbacks parameter while fitting the model. So I'll come back to it again in the example, how to use it. Yeah. So here you can see clearly that while implementing early stopping, you just have to write monitor equal to early stopping, specify the monitor which validation loss, minimum delta is 0.001, patience is 5, and verbose is, you don't need to talk about verbose right now. It just tells that how much log you can see during the training process. And there's another thing in early stopping, which is the checkpoint. So it happens rarely, but it can happen that after certain epochs, the model loss is actually going worse, or the weights are not the best after a certain epoch. So if you are stopping at 20 epochs and the best weights are at iteration number 12, so you can save the best weights as well by using this model checkpoint command. So what model checkpoint does is you save the best weights while training and then load them after the trained model. So here, after implementing early stopping, then we implement model checkpoint, which basically saves the best weights at this file location at this name. So after running the model, the weights file will be saved as best_weights.htf5, and you just need to include this checkpointer with the monitor in the callbacks block while fitting. So previously we just had monitor here, for early stopping, and if we want to save the best weights, we can also just write check pointer, which we have previously in the previous line that we have created. So after fitting this model, when we want to run it on test data, we can just load the best weights on it. So it will replace the all weights which are already present in the model to the best weights. And this is a typical simple example of multi-layer perceptron for binary classification. This is a model from start to end. Just have to import the libraries numpy, and then in Keras you have to import model. We are only using sequential model here, and then dense and dropout. So for creating the data, we use the random function available in numpy. So for to create 1000 rows of 20 features, and then for the label part, we also use a random function. Similarly, for the test case, we generate 100 rows of 20 columns and the labels as well. And then using Keras, which comes here, we first specify that what type of model are we going to use. So model equals sequential means we are using a feed-forward neural network. And if we want to add any layer on it, we just write model.add dense 64. Dense means it's a dense layer. 64 means the number of neurons in the first hidden layer. And the input dimension is 20, and the activation function used is relo. So as you can see that the input dimension is 20, but the number of neurons in the first hidden layer is 64. So it's a wider model. So input dimensions are less and the model dimensions are bigger. So it's a wider model. So 20 features are mapped to basically 64 neurons, and we can use the dropout function as well with a ratio of 0.5 to drop the neurons in that layer for regularization, and then add another hidden layer similarly of 64 neurons and same activation function, and then implement the dropout, and finally the output layer, which just consists of one neuron because we want to find the output, and the activation function used is sigmoid because we are doing classification. So a model is now specified which has an input layer, two hidden layers of 64 neurons, and an output layer. So it's a 4-layer network: input, two hidden layers, and an output. And while compiling this model, we just have to write loss equal to binary cross entropy, optimizer is equal to, yeah.
The first step, like your model add the input dimension, but we can see also from the training data, we know the input dimension is 20, right? So is that one optional, or like do we need to
no, it's
specify?
not. It's not optional. We have to write this. Yeah, I know. I don't know why, but we have to write.
Yeah.
So sometimes people don't want to use all the features in the hidden layer. So I don't know why they didn't make it optional, but if we don't write it, it gives an error. Okay. And for compiling, I was mentioning the loss function here is used as binary cross entropy, optimizer uses RMS prop, and the metric used is accuracy. So when you are compiling the model, it shows you the loss value, which is in this case binary cross entropy. But if you want to see others metrics as well, say mean absolute error or something, you can also see that while training for each epoch. So when we train, we can see the value of binary cross entropy, which is the main loss function, which is adjusting for the weight matrix, but we can also see the accuracy of the model as well. In this matrix block, we can write accuracy, mean absolute error, mean square error, whatever we want. And lastly, while fitting the model, we just have to write the input feature matrix, label matrix, the number of epochs, maximum number of epochs, and the batch size. So as we know that our CPUs and GPUs are not capable of handling all the data at once, so we use mini batch while training. So that's why we have to use more than one epoch. If we use all the training data at once, then we don't need epochs. So yeah, and this last score is equal to model.evaluate. This is not predicting the data, it is just testing.
Not sure about, yeah, sorry for interrupting again. I'm not sure about your comment, like, if you use all the training data, then you don't need epoch. I mean, you can just, because you still do iterating, right? You're still doing like RMS properties, like essentially doing steepest descent and so on, right? So.
Okay.
Yeah, I just want to make sure I understand what you're
Okay.
talking about here.
Okay, thank you. And this evaluate command is just trying to evaluate the test data set on this model, and the values of binary cross entropy and the metric final value of these two parameters will be stored in this score vector. So after we check the value of this score vector, we will see two values. One will be of binary cross entropy and the second will be of accuracy, which we have specified. So it's not the prediction command, it's just evaluating the score of the loss function. So if you need any further examples as well, I have a couple of other examples as well if you want. Otherwise, that's if you want, I can go on or just stop here.
I didn't understand this thing. Model evaluate. Did you?
Dr. Sam, I was asking if I should finish my presentation or go with another. I have a couple of more examples as well.
Yeah, I don't know, like, he has a question also, right? What did he ask? I didn't get that.
Charles here was asking what's the purpose of this model.evaluate function?
No, I
So-
didn't understand. You said that optimizer and matrix value,
Yes.
binary cross entropy gets stored in the score, right?
Yes.
So how does that happen? Like
So when I write this command model.evaluate
okay,
x test y test, so it will run the model and try to predict the value of y test.
okay,
So by just giving the input x test, it will predict the value of y test,
okay.
and then compare the performance of prediction and actual y test values, and the matrix that it's using is, one is the actual loss function and other one is the accuracy. So these two scores will be saved in this score vector.
Okay.
It's how Keras
I
works.
got it. Yeah.
Okay, I have another question.
Yeah.
I didn't really understand the significance of that dense function in the model.add dense.
Yeah.
I mean, when we're just specifying the number of input neurons and output neurons,
Yes.
why do we need to also say that dense?
So you can see here that Keras has multiple type of layers.
Okay.
So one is dense and other is dropout, which is called.
Okay, so it's
So
from that
when I'm
package.
adding a hidden layer, I need to say dense, and when I'm adding a dropout layer, I need to say dropout. So
Okay.
to uniquely identify different types of layers.
Okay. Thanks.
So, what is a dense layer?
So it's a hidden layer with 64 neurons here. So it's a typical hidden layer. Dense is used to specify a typical hidden layer.
Sorry, like, I got some noise here. Can you repeat that?
So dense is a type of layer in Keras, and dropout is another type of layer in Keras. So when I want to add a hidden layer to my neural network, I need to write model.add and then dense. This means that I am adding a new hidden layer in the network. And if I write model.add dropout, it means that I am using the dropout layer.
Yes, But do you know what is dense stand for? Like what kind of layer is that?
No, sorry.
So,
I have a question in regards to your activation using sigmoid. Did you observe any type of negative responses regarding the gradients, like any type of vanishing gradients or exploding gradients?
This is actually not the code that I have run on. I basically took it from that website keras.io. So I don't actually know the values of the gradients that were run on this particular example. So,
Okay.
so it's just for explaining how the syntax of Keras works.
then should be just fully connected layer. Yeah. Yeah. I mean, I will wait for some of you guys to answer that, but yeah.
I thought that's it. Understand?
Yeah. So, and I'm curious about this dropout layer also. I assume when, okay, the way you put it is like you add an additional layer, but I'm thinking it's just describe the previous layer saying that I'm going to use dropout with like 0.5.
Yes.
Oh, what ratio for those? Okay, yeah.
So yeah, dropout is not actually a layer, but in Keras it's written as it is included in the layers package. So that's why we have to write it this way.
Okay. So did you try to run the code like this one?
I am using Keras in my research, but I haven't included that code here. So
Yes.
so
So when you run this code, how long did it take? Do you try this on a PC, like with GPUs or like no GPU?
I will tell you about my own research that I am doing.
Yeah.
So in my research, I have created a data set of around 80 million rows, and I have created a deep neural network of 4 hidden layers, and the input dimensions is 8. So this, to train 80 million training data, the CPU actually takes 4 hours per epoch on a GPU. So the GPU that I am using has, I think, has 2500 cores and 8 GB. I think it's a M4000, Quadro M4000. So what I do is, as I don't have enough resources, I use the test train split method and only use 20% or 10% of the whole data, because it randomly divides the data. So what I do is I reduce the data, because in my application the quantity of data does not matter that much as if I cover the whole distribution of data. So what I do is I make the data sparse enough so that I can run it on my own computer. So, but yeah, it takes very long time if I run it on my own computer. 4 hours per epoch means 400 hours for 100 epoch.
Yes. So you're running on a laptop, is that like?
Yeah, it's a laptop. Yeah, Core i9 and 8 GB of. It's a good laptop.
Okay. So any other questions? So any other questions from Tulsa as well? So who is the first speaker for Keras? Is it? Oh, you're the first one. I mean, third. It's hard for me to pronounce that.
I'm third.
Oh, you're the third one.
Yeah.
So I thought those. So then you can check out why we should use TensorFlow at all. Like, why we?
Yeah, I can check it out.
Okay.
I'll tell you on Thursday.
So okay, I guess that's good. And well, remember, you guys should wait the presentation and like hopefully put some constructive comments also, like how, what do you think like they are doing good and what you think like they can improve next time, stuff like that. So, looking for thank you for taking that, like, I'm not sure Mookie is still here.
Yeah, I'm here.
Yeah, okay. So, yeah, please upload that like to whatever YouTube and send me a link, then I can share it to everyone.
All right.
You can, I don't know, you can upload as a list, unless you guys don't mind to be public. So,
It's fine.
Yeah, they don't mind if it's public. Yeah.
yeah, either way, it doesn't matter.
Okay.
It's up to you guys. Okay, well, I guess we just, it's so nice that it's so relaxing sitting here. So I'll just do you guys like next week. I'm in love next week. Personally, it's too happy that I was thinking, I'm grateful. So we'll come back this Thursday, I guess.